Okay, so I wanted to talk about substitution in factoring polynomials. So when you're factoring a polynomial, sometimes you'll come across this form of polynomial. So it will be a f of x squared plus b f of x plus c. Now, this is pretty much the same as any regular thing, but it will have f of x instead. So an example of this would be a sine of x squared plus b sine of x squared plus c. Okay, so how you solve this is a lot simpler, very simple, a lot simpler than it may seem. What it basically can do is you can just replace the sine of x with an x, and then replace the x with the sine of x later on. So here's what I mean. You can rewrite it as ax squared plus bx plus c, and then you can solve for it later on. So let's try an example. Let's say we have 12 sine of x plus 13, sine of x squared plus 13 sine of x plus 1. Okay, and this ties into our previous video about coefficients. Okay, so we can just rewrite this as 12 x squared plus 13x plus 1. Okay, so now we can find the two numbers that will add up to 13, and find the two numbers that will multiply together to equal 12. 12 times 1. And these numbers work to be 1 and 12. Okay. So now all is left to do is simplify and substitute later on. So you can go 12x squared plus 12x plus 1x plus 1. So you see how I split the 13 into 1x and 12x. And now we can just start to factor. So we can pull out a 1 here. We can go 1 times x plus 1. There's not much else we can factor out. And then we can pull out a 12x here. Okay. And then we get 12x plus 1 multiplied by x plus 1. Okay, so we're almost finished. But all that's left to do is replace the x with the sine of x now. So we go 12 sine of x plus 1 multiplied by sine of x plus 1. And that is our answer. So it was pretty much the same, except we just had to resubstitute and desubstitute. So yeah, it's pretty simple. Thank you.